I want to talk about how to create functions that search for things inside of an array. I like to call this thing, I like to call the technique here mouse traps. That's just a phrasing that I've made up myself. You probably won't hear anyone else ever talk about that. But let's go and see if we can create a function that says contains. So let's write a function that accepts an array, and it's going to tell us whether the array includes a certain value. Return true if the given array contains the given value. So we can say contains 14, 55, 67, 88. 67 would return true. And if we searched for 66, that would return false. So, how can we write a function like this? First, we need the general idea, which is we know that we can use a for loop to go through an array. So let's say we have a for loop which has a value I, which starts at 0. We will execute the loop as long as I is less than the length of the array. We always increment I by 1. And what we can do here is we can say if the array at I is equal to the value that we're looking for, we can immediately return true. And if we manage to go through the whole array without ever seeing the thing that we were looking for, we can ultimately return false. So let's see if this works. So yes, the first one, the element was in there, and the second one, it wasn't. Let's see what should happen. We're always supposed to consider the empty case. So let's make sure that our function handles an empty array. So there, this reports it correctly. If we have an empty array and we're looking for something, it's never going to be true. Let's write another function called isSorted. For this one, returns true if the array is sorted in ascending order, where each element is greater or equal to the element preceding it. So here, we need to do two things. We need to visit everything in the array, but since we have this, this one actually requires some pairwise comparison. The previous one contains, we are only looking at every element in the array and seeing if that one element was the thing we are looking for. In this problem, it's a pairwise comparison, where we need to look at two elements at a time in order to see if they're ever not in a sorted order. So that means we have to use the technique where we are very careful to not access something before the beginning of the array or after the end of the array. I'm going to start I at 1 and say continue as long as I is less than the length of the array, and always increment I. I like to start I as 1. I don't like to do that length minus 1 thing over here. I just think this looks more elegant. It's a personal decision. So I'm going to say here, if the array at I minus 1 is ever greater than the array at I, return false. So in this example, we are comparing everything in the array, and as soon as we see something that invalidated the sortedness of this array, we can immediately return, and we can return false. So in this case, we're moving through the array, and if we ever see something where a larger value appeared before a smaller value, we know immediately that the array must not be sorted, so it's safe to return false there. And if we made it through the entire array and we never saw something that broke the sortedness, that means we can return true. So let's see. Let's try this for a empty array. Let's try it for a 1-element array. Let's try it for a 1 and 2-element array. And let's try it with an array that is not sorted. So it looks like it works for the empty array, 1-element array, 2-element, for an array with a bunch of stuff in it, and it does not work when there's something in there that's not sorted. I think it's also a good idea to check the bounds, and let's make sure that it can detect this everywhere in the array. So let's see if it can detect if it's not sorted in the very beginning, or if it's not sorted at the very end. And maybe let's put in a special case here where every value is the same. And if it's all the same, then I believe that should still count as being sorted. Here, I want to switch these just so that so these are all the true cases, and these are the false cases. So we have 1, 2, 3, 4, 5 true, 1, 2, 3, 4, 5 true there, and some false ones there. So the point of this one is just showing that you can sometimes return immediately as soon as you see something wrong. And the converse of that is, since you're returning, if you ever get outside of a for loop without finding something that caused your program to return in a satisfying manner, you can always return the opposite. So here we're looking through the array, and if we find it, we know that the function is going to return. That means that if we ever got through the entire array and we ever got to this line, we know that it wasn't in the array, so we can return false. Similarly, for the sortedness, if we ever see something that is not sorted, we return false. Basically, what we're doing is we're assuming the array is sorted until we find out something that is not sorted. So if we ever see that it's not sorted, we can return false immediately. Otherwise, we have to check the entire array And if we make it through the entire array without seeing something that breaks sortedness, then we can return true at the end.